Hello everyone. Our next lesson, and this is the second to last lesson in the vector section of the course. Okay, we talked in the previous lesson about the different ways that three planes can intersect. So now we're going to look at actually finding the solution to those. And remember, solutions really only come up, at least a full solution, a consistent system, if you have type 3b or type 4. Okay, so when we have a system of equations, our first goal will be to establish what type of system we have. So the first thing I'm going to do here is just write out the three normals. So if I call this plane 1 and 2 and 3. Okay, so my first normal is 1, 1, 1. Okay, my second normal is 2, 1, 3. And my third normal is 2, negative 1, negative 2. Okay, so having a quick look at these, they're clearly not scalar multiples of each other, right? This one is 1, 1, 1, so I'd have to have the same number 3 times in a row. These both have a 2, and the other numbers don't match. Okay, so it's not type 1, it's not type 2. Okay, so no parallel planes. Okay, so now it's a question of, is it type 3 or type 4? So my next test is to do the triple scalar product. So I'm going to test for coplanarity. Okay, so I'm going to do the triple scalar product. And again, to make my life easier, I think I'll put the 1, 1, 1 into the cross product. So I've got 2, negative 1, 2, negative 2, dotted with 2, 1, 3, which is crossed with 1, 1, 1. Okay, so we'll zip through the cross product here. So I've got 2, 1, 3, 2, 1, 3, 1, 1, 1, 1, 1, 1. Okay, so I have 2, negative 1, negative 2, dotted with, see, I have 1, take away 3, so that's minus 2. I have 3, take away 2, that is 1. And I have 2, take away 1, that's 1. Okay, and now we do the dot product. So 2 times negative 2 is negative 4, plus 1 times negative 1 is negative 1. Negative 2 times 1 is negative 2, so I get negative 7. Okay, so therefore, this is a type 4 system, right? The triple scalar product was not equal to 0, so I have type 4. Okay, so now that I know that, I'm ready to start solving the system. Okay, I'm just going to copy it down again so I can see it here. Okay, so the way we're going to do this is basically what we've been doing all along. We want to do substitution elimination, something like that. Okay, elimination is probably the easiest way to go, but you can start rearranging things, you know, say bring x and y over and sub it in for z. Okay, you can do that, but I find that elimination is a bit cleaner. Okay, so the goal here at the start is to reduce this to 2 equations with 2 variables. So let's say we'll start by eliminating x. Okay. Again, you can go anywhere you want, but I'm going to try eliminating x first. Okay. So my second and third equations, actually I should probably not use that label there. Because I want to include 1, 2, and 3. This was my 1, 2, and 3. Okay. So looking at my equations, okay, one way I can eliminate x is to use equation 2 and equation 3. So if I write these out, I've got 2x plus y plus 3z equals 17. 2x minus y minus 2z is equal to negative 5. Okay, and I'm going to subtract to eliminate x. So my x's cancel. Y take away negative y is 2y. 3 take away negative 2 is positive 5. And 17 take away negative 5 is 22. Okay, so I've got one equation with just y and z. Now I'm going to pick a different pair of equations and try to eliminate it. So let's say I wanted to use equations 1 and 3. Okay, I would have to double my first equation and then subtract my third equation. So I'm going to make a little note of that here. Okay, I am doubling equation 1. So I have 2x plus 2y plus 2z equals 14. And I'm just going to leave equation 3 the way it is. 2x minus y minus 2z is equal to negative 5. Okay, now I am going to subtract those two things. So subtract. And let's see what we get. My x's cancel out. 2y take away y is 3y. 2z take away negative 2z is positive 4. And I get 19. Okay, so now I have two equations that just involve y and z. So I'm going to call those equations 4 and equation 5. So now I'm going to try to eliminate another variable from this pair of equations. So if we just go in order, let's say I'm going to try to eliminate y next. Okay, so looking here, I have a 2y and a 3y, so that means I'm going to have to multiply this equation by 3. So equation 4 times 3, and equation 5 will need to double. So equation 5 times 2. So I get 6y plus 15z equals 66. Okay, and for equation 2, I'm going to get 6y plus 8z is equal to 38. Okay. Now I'm going to subtract and see what I get. So 6y's cancel. 15 take away 8 is 7. Okay, and 66 take away 38 is 28. So now I've got it down to just z, so I can solve that for z. So we divide by 7, and z is equal to 4. Okay, I got my first variable. So now I start climbing my way back through this and substituting to solve for the other variables. Okay, so let's say I'm going to substitute sub z equals 4 into equation 5, just because I'm close and I can see that one right here. So 3y plus 4z equals 19. Okay, so I had 3y plus 4 times z, which is 4, equals 19. Okay, and now I can solve that for y. So 3y equals 4 times 4 is 16. Bring it over. I have 3y equals 3. So y is equal to 1. Okay, so now I've got y and z. I return to one of my original equations up here. The first one is really easy, so we'll use that one. And now just solve for x. Okay, so we're going to sub y equals 1 and z equals 4 into equation 1. Okay, so my equation at the very top was x plus y, which is 1, plus z, which is 4, is equal to 7. Okay, so x plus 5 equals 7. X is equal to 2. Okay, so therefore, the planes intersect at the point 2, 1, 4. Okay, and that's basically the whole thing. So just it's the same as the elimination process you've done in the past. It's just longer. Okay, there's more steps to do. Okay, and again, just to go through that roughly again, right? The goal at the very top was to eliminate one of the variables, right? So I picked x. We used two different pairs of equations to eliminate x, right? That gave me two equations in y and in z. Then we tried to eliminate a new variable from this pair, okay? And so we picked y, we got it down to z, and so on. Okay, and that's basically how it goes. Okay, that process to run this through. Okay. This would extend in general to like systems with 4 equations. If I had w, x, y, z, right, I would have to have 4 equations, and then I would pick, 3 different pairs to eliminate w. Then I have 3 equations with 3 variables. I pick 2 different pairs to eliminate x. Okay, and the whole thing would just repeat itself. Okay, so we're going to do one more. So here's example 2, and we'll just go through that process again. So again, my first thing, I want to see if any of these things are parallel to each other. So I'm just going to list out the normals. Okay, so my first normal is 1, 3, and -1. Okay, my second normal is 3, 8, and -4. Okay, and my third normal is 1, 2, -2. Okay, again, a quick look at that would show that they're not parallel. Obviously, the first and the third can't be. And then for this, I have a 3 and an 8. So if I multiply the first one by 3, neither of those are going to give me an 8. Okay? So we have no parallel planes again. So no parallel planes. Okay, so now we have to do the triple scalar product and see what happens if it's type 3 or type 4. Okay, so we now do the next test. We can write test down here. Again, to make my life easier, I'm going to put the normals with the smaller numbers in for my cross product. So I'm going to do 3, 8, -4, dotted with 1, 3, -1, crossed with 1, 2, -2. 1, 1, 2, -2, 1, 2, -2. 3, 8, -4, dotted with. Okay, so I have -6 plus 2, so -4. I have -1 take away 2, -3. And I have 2 take away 3, so -1. Okay, and I realized I just made a little error in here, so let's go back and fix that. Okay, this cross was -1, and that's really a -2. I just missed it, so it's plus, so that should be a 1 sitting there. Okay, so now we do the dot product. So I'm going to get -12 plus 8 plus 4, so this is equal to 0. Okay, so therefore, this is a type 3 system. Okay, I do not know if it's type 3A or 3B. We just have to run through the process and figure it out once we start solving. Okay, so I'm going to copy down my equations and we'll start the process. Okay, so if I'm going to eliminate x, the first pair I might choose is to use equation 1 and equation 3 because they both have the same x there. Okay, so I've got x plus 3y minus z equals 4, and x plus 2y minus 2z is equal to -4. So I'm going to subtract those two equations. And so my x's cancel. 3 minus 2 is y. Okay, negative 1, subtract negative 2, okay, is 1z. And 4 take away negative 4 is 8. Okay. Now I'm going to pick another pair. So if I want to use equation 2, I'll have to pick another equation and multiply it by 3. So let's say I'll use equation 3. Okay. So I'm going to keep equation 2 the way it is. So 3x plus 8y minus 4z is equal to 4. And I'm going to take equation 3 and multiply it by 3. So I get 3x plus 6y minus 6z is equal to negative 12. Okay, so now I will subtract and see what we get. So x's cancel. 8 minus 6 is 2. 4 take away negative 6 is positive 2. And 4 subtract negative 12 is positive 16. So a quick thing I'm noticing here is that these are all divisible by 2. Okay, or I could bulk this up by 2, but I'll just go ahead and divide this by 2 right now. So this is y plus z is equal to 8. Okay, so our next step, right, was to go to our new equations 4 and 5. So this is equation 4, this is equation 5. Okay, and continue eliminating. So the y's are the same. So I just need to line up equation 4, y plus z equals 8, and equation 5, y plus z equals 8, and eliminate. So I would subtract to get rid of my y's. So the y's cancel, the z's cancel, and the 8's all cancel. So I get 0 equals 0. Okay. So we encountered this before when we did solving the system of 2 planes. 0 equals 0 means that there is an infinite number of solutions, because this is always true. So these planes must meet in a single line. So this is the proof that this is type 3B. Okay, because I got to 0 equals 0, that means there's multiple solutions, so they share a line, because all the points on that line are solutions to the system. Okay, if I got to this step, okay, so there's an aside here. If I got to that step and I had something like 0 equals 10, okay, that would tell me I was in type 3A, and I would know there is no solution that works with all 3. Okay, it would be 3A. The pairs meet in different lines. Okay, so now that I know it's 3B, and I know they meet in a line. Okay, we're going to go back to equation 5 for a second here. Okay, so now I need to create a parameter and create the equation of my line. I said all that clicking, and I know it's not going to work. Okay, so this is where we do the whole let z equal t piece. Okay, so from equation 5, I have y plus t is equal to 8. So I bring the t over, so y is equal to 8, giving me minus t. Okay, there's my second parameter. Okay, from my third parameter, I need to go back to one of my original equations and sub in both y and z. So let's say I take that first one, so x plus 3y x, so now sub y and z into equation 1. So that was x plus 3y, so y is 8 minus t. And I think that was, let's check, it was 3y minus z is equal to 4. So minus z, which is now just t, is equal to 4. Okay, and we're going to solve this for x. So x plus 24 minus 3t minus t is equal to 4. So I've got negative 4t. When I bring that over, it'll become positive 4t. And I have 24. When I bring that over, I'm going to get negative 20. So x equals negative 20 plus 4t. Okay, so there are my parameters. X is negative 20 plus 4t. Y is 8 minus t. And z is equal to t. So I'll write that out in a couple different ways here. Right, so one way to write my line is that x equals negative 20 plus 4t, y equals 8 minus t, and z equals t. Okay, or if I wanted to write that in the vector form, okay, it would look like, right, x, y, z is equal to, my point is negative 20, 8, and 0, plus t, and my direction vector is 4, negative 1, and 1. Okay, and we're done. Okay, so those are really the two cases that can show up for solving a consistent system. Okay, if it's type 4, it will lead you to a point. If it's type 3b, you'll end up getting the equation of a line. If it's none of the above, you would be doing something else, right? Like if it was type 2, for instance, and said solve for the intersection, okay, it doesn't have a solution that works for all three. Okay, but it could solve for the separate lines using the techniques from two planes. Okay, so that's it. Okay, there is the practice work from the same section you were looking at yesterday. So now you're also just going through and trying to solve the equations as well. All right, thanks for watching. And there's one more vector lesson to go the next time.